I believe it's from 2. Is that right? Okay, so thank you very much for coming to my talk. I hope many of you here already know what Jenkins is. How many of you already know what it is? Well, thank you very much. So just, I guess, to kick off the context, Jenkins is currently, I think, the most adopted open source continuous integration server on the market today. We count more than 53,000 installations around the world, each of them being a server application supporting many users. There are a couple of things that we really care about in Jenkins project. The one is to make it easy to install and easy to use. It needs tools like this is all about productivity, so we wanted to make it as easy as possible. The other thing is the extensibility, because we have incredible diversity in what we do, ranging from different languages to tools, to web apps, to the package apps. We need to be able, the tool needs to be able to adapt to all these use cases, and the only way to do it is by extensibility. So we have today more than 600 plugins integrating Jenkins into all sorts of things you can imagine, including Chuck Norris. But I have so as a creator of Jenkins, I get a lot of opportunities to go in and see people's Jenkins instances, and to see the way they use it evolve over time. I think the first step of using a continuous integration server is pretty obvious. You want to run the build, you want to run the test automations, and so on. But how you evolve your use from there, it's not that obvious. And I see that the people, once they got to the point of automating the test executions, they seem to stagnate a little bit, that they aren't quite sure where to go from here to the next step. So today I wanted to talk about all these things, I guess, so that you can do on top of Jenkins, and then what kind of plugins and tools we provide to help you do that. So put quite shortly, I think the thing that the most people are trying to do, those who decided to go to the next step, is really what I call as a workflow. And what I mean by workflow, I mean the jobs that are interconnected together to do some interesting things. It provides a larger scale automation that cuts across different teams. So the terms like continuous delivery, which basically means not only automating the build and test, but also hook up the deployment and the test that happens after the deployment. It is a kind of workflow because you're chaining together all these different things. But that's not the only kind of workflow, and hopefully I'll be able to give you some insights into what these things are. So why are we interested in all these workflow or the automation that's at the bigger scale? I think one of the reasons is because these are the places where the work piles up really fast. The automating things that you have entire control of is relatively straightforward. I mean, there are technical challenges, but it is relatively straightforward. But when you have to work between different teams, which is, say, you're a member of a development team and you have to work with the QA guys because every so often you need to hand over the binary that the QA guys will test. And for you to hand over the binary to the QA guys, well, you have to run some sanity tests on your side. So these are the kind of workflow that today I think mostly happens without good automations. And so that's, in my mind, is the prime reason why this large-scale automation is useful. Another reason I think this is important is, especially so in Jenkins, the unit, the building block of these automation, it's called job or project, is not meant to be the complex whole thing. It's meant to be a composable, reusable, almost like a Lego building blocks, and then you derive the power where you sort of create what you want by combining these individual pieces. So that naturally calls for this ability to do workflow and automations. And finally, by decomposing your workflow into smaller individual blocks, you'll be able to reuse these things. Right? Say you're thinking about the performance test. That might consist of having this setup phase where you start the servers, deploy the applications, prepare the loads generating clients, and so on. And maybe the next step might be to actually run the performance test. And then followed by the teardown phase where you shut down all the servers, collect the logs, analyze the reports, and so on and so forth. So in this kind of setup, it is often common that the actual performance test that you might want to run could change. You might want to run a smaller set, you might want to run a bigger set, and so on. So being able to reuse the setup phase and teardown phase, that's often useful. So that's the kind of thing. So all these things, I guess, point to this, what I call as workflow, the jobs that are interconnected together to do things that are useful. So what are the building blocks that Jenkins provide to help you do this? The first one that I wanted to talk about is the parameterized builds. So if you're, presumably most of you are already using Jenkins, so you know what it's like to define a job. It's somewhat like defining a procedure, right? You tell Jenkins to check out the source code from this location, followed by maybe running Maven, and then look at the find bugs report. If the build is broken, send email, things like that. So it's basically step-by-step described to Jenkins, and then all that Jenkins is going to do is to simply repeat that process over and over again. Now, if you think of what Jenkins is doing as a procedure, it is often, I think it's not hard to realize that it would be very convenient to be able to define the parameters and arguments. So perhaps if you're doing the test, you might want to be able to specify the binary to be tested as an argument. If you're building the C++ project, you might want to be able to specify the target platform where it runs. So these are what the parameterized build enable you to do. There's really only 3 things you need to do to parameterize your builds. The first step is, as an owner of the job, you define parameters to your job. So there's this little checkbox that you can set that this build is parameterized checkbox that opens up this subsystem of Jenkins. And then you click this add parameter buttons to insert the parameter types. In this screenshot, I put the string parameter, which means the user will be typing in a string. That's why it's called string. But this is not the only available parameter type. Indeed, you could specify all sorts of different interesting inputs, ranging from, let's say, something simple like checkboxes to radio buttons. But it gets really more complex and interesting stuff like specifying branches in subversions. So imagine, you're having this expensive test job, and then the developer would be able to simply kick that on their favorite branch simply by selecting it. So that's the kind of thing you can do with the parameterized builds. And then now that you define a parameter, you need to update your build to defer to these parameter values. So you use the familiar variable expansion syntax, the $bracket, and then specify the name of the variable that you defined. And in addition to using these things everywhere in the Jenkins configuration field, you could also refer to those from your build by using environment variables. So most of the build tools and test automation scripts that you have can probably very easily access the environment variables. So this is how you could alter the behavior of your build based on the actual parameters given. And there are some parameter types that don't fit into this model, most notably the file parameter, where the user is allowed to upload a file. This is actually very useful for a number of reasons. Obviously, the contents of the file will not fit into a single environment variable. It'd be too big. So what Jenkins is going to do is simply put that in the file system by the name of the variable, and then you'll be able to access those from your build script. So that's what you do as a job owner. And then once those configuration is made, the user who is going to start the build is simply going to click this Build Now button. And instead of build starting right away, they'll be presented with the UI. So in the previous screenshot, I defined the single string parameter where I guess the demo use case is that you're testing your web application by different browser through Selenium or something like that. And so you see this UI where you basically configure it as is. So once you define the parameters, these functions, remember that we are sort of thinking of the build jobs as the functions. So naturally, the next thing we wanted to do is to compose these functions. So there are obviously lots of interesting ways to compose functions, but there are certain very common patterns that showed up in the choreography in many places that there are dedicated support for these. I suppose more accurate reason why these things are in separate plugins is because historically our attempt to embrace the workflow started small. So these are the very early plugins that spearheaded this field. And then as we will see later, some of these things can be effectively superseded by, can be sort of overridden by using other plugins. But anyhow, the Parameterized Trigger Plugin, what that allows you to do is essentially allow one job to call other jobs, and if necessary, by specifying arguments. So I talked about this performance test use case where you might have setup, followed by the performance test, followed by the teardown. And by having this overall foo that encompasses the whole thing, you'll be able to easily correlate the setup run from the actual performance run to the analysis of the third step. And then it also provides the necessary mutual exclusion semantics because you don't want to be running two of these at the same time. As a variation of this, as depicted down below, you could also fork multiple different jobs at the same time. So this is very convenient, for example, if you're trying to parallelize the test executions, and then you could easily run as many as you want, and then wait for the entire things to complete, then move on to the next step, which I think is also a very common pattern. Another thing that's often common, in fact common enough that it provides this, the dedicated support is the join plugin. So what join plugin does is, well, this is I guess a simpler form of the parallel executions. As we saw earlier in the parameterized trigger, it is often convenient to be able to run two things in parallel and then wait for both of them to complete and then move on to do something else. So the join plugin was one of the earliest plugins that just provides this construct. So now that, again, as I said, we have a lot more complete plugin that covers the entire workflow use cases, the users who benefit from this become, I think, somewhat limited. But oftentimes, people are still really doing simple things. And in those cases, there's not much point in bringing a big gun. Right? So if the join is all you need to do, this is a perfectly fine plugin that's used by many thousands of people. Another useful building block, when you try to put multiple jobs together to work as a collaborative workflow, is to be able to pass files between different job executions. Right? So imagine, let's say, the continuous delivery scenario. You might have the build job that produces a jar file or the ear file or whatever you do, and then there's a separate job execution that tests these binaries. So you need to be able to copy this stuff over into the other side. Now, if you're using Maven, for example, you might choose to do this through the external repository managers and so on. But if your system isn't all that complicated, this is often just as fine to be able to copy files from one build to another. And then this functionality is provided by this copy artifact plugin. And the neat things about the copy artifact plugin is that it allows you to specify various criteria. What do I mean by various criteria? Right? If you think about the fact that the Jenkins is running lots of builds of the same job, the result that these builds produce is almost like the version-controlled binaries. Right? For every build all the way down, each of these has its own jar file. And then often they do excuse me. Often they have different outcomes. So some of those might pass all the unit tests, which means they are stable. Some of them might not pass all the tests. Right? So Jenkins has these, what we call as permalinks, which identify the build that satisfy the criteria, the latest build that satisfy this criteria. So in this picture, I took that, well, the last build that passed all the tests was build 14, and then 15 didn't pass all the tests, perhaps. Jenkins also allows you to sort of mark the build as persisted, that's manual actions, and these things could be also often useful informations. So when we are talking about copying build into test, well, it'd be really handy if you could say, well, it doesn't make sense to test anything that didn't complete the whole developer unit test. In which case, we'd like to be able to say, well, the test job should grab the last stable build. And then that often achieves what you'd like to do. Now, these built-in permalinks, like things like last stable build and so on, is useful to a certain extent, but it gets a lot more interesting if you could define your own permalink, shall we say, right? Because often, when the teams are working together, there's this state in which the binaries are declared to be in. For example, I am a member in the development team. So for me to pass the binary, well, so my workflow is I pick up the binary that's good enough for the consumption of the QA people, and then I sign off to the QA people. And they trust what I'm saying. I mean, I do certain things to verify that the bits are actually good. But ultimately, for the people doing QA, for the people in the QA team, what really matters is not how I validated it, but the fact that I'm handing over this binary to him. So that's the value it brings if you could define your own labels like these. But let's not stop there. Well, I mentioned that I'm doing certain work to validate these bits, right? So what are they? Well, the chances are I want to also automate these processes because these are probably test executions. So as a developer, the way I'm working would be that I got this build that this job, I own this, well, my team would own this job. It's producing the jar file. And then before I hand it over to the QA team, I'd have maybe a few other jobs that validates these settings. So one might be a bit more extensive set of testing, and then another might be defined bugs executions. And the way I define my workflow is that if the binary would successfully pass these two jobs, then I declare this binary signed off to the QA, and then so I attach these labels. So if we could ask Jenkins to automate this whole process, including assigning labels and whatnot, then we could sort of automate the whole thing into the next level. So that's what we do in the Promoted Builds plugin. Those of you who were here yesterday, I apologize that there's a bit of overlap here. But the reason, so this promoted build, the reason it's called promotions is because where I used to work at Sun Microsystems, this was how we actually worked. And then so this was a straightforward implementation of how we worked. And I believe that it's got a broad applicability in other development environment. So here you'd specify the promotion criteria. In the earlier example, the build gets promoted when it passes the dev test and find bugs. And then we would also specify what happens as a result of promotions. Maybe I'd be copying the binaries into some shared location. This might be actually a good time to deploy binaries to the Maven repository if I were using Maven, because now I have a bit more confidence to these binaries. And then above all, these labels, the label like signed off to QA, provides a nice handoff point between different teams. I entirely control how the build gets this label of signed off to QA. It's up to me, and as I evolve my development process, I might add a few more tests to it. I might change the way things are run in certain order, and it shouldn't really matter how I'm doing this to the QA people. What matters is the fact that I'm signing off this binary to them. So it allows us to hide the sausage-making process from the QA people as a developer. And the same thing happens between the QA people and the deployment team. No matter how the QA people uses these Jenkins or the other kind of build automations to run the test, we don't have to expose those to the development team. So let me show this quickly. So here I got this one job called the CI. Let's say this is the one where we are building the binary. So because this is a demo, instead of actually building the binary, all that I'm doing is to create this jar file that has a unique content. And then I specify this. I capture the file so that I could use it elsewhere. And as a developer, I own this development test, so I'm making it run as soon as my my binary get ready. So the development test in this case is really nothing more than just a test script. All I'm doing is to make it test of pass or fail randomly, but you'd imagine that in the actual test, this would be a lot more a real thing. Now, what makes a promotion is going back to the CI job. If we see the configuration screen, I got this promote build when the checkbox applied, and I defined this one label called the one promotion process called the handed off to QA. And the way I declare that success is by making sure that this binary has successfully passed the ACME dev test. So as you can see here, the promoted binary gets this gold star. So these are an indication that these binary have actually get promoted. So if we run these guys, we'd be able to see that every other build gets promoted because that's what our tests are configured. Now, so this is where it gets interesting. So you notice that this build actually is not yet promoted, but if you reload the page, now it is, because it does take a little bit of time to promote the thing, basically the time it takes to run the test, which is reflected here. And as a QA person, now let's switch to what the QA person do. If I'm automating what I do on Jenkins, what I'm going to do is my job is triggered when the promotion happens in a CI job, the job that's owned by the developer. I don't really care how this promotion is achieved, but if it happens, well, I'm going to first copy the binary from this CI job, the build that was just promoted, and then I run the test against it. So in this way, as a QA guy, I won't be bothered by the builds and tests that have happened since the original build was made available, and I'll be always testing the bits that was actually promoted. So in this way, also, as you can see, those jobs that's owned by two teams are entirely separated, aside from the one that actually produced the binary. So that's just a quick overview of this. Now, these copying files would really only work when you're using something like AND, right? That's what indeed we were doing at Sun back then. But for people using Maven, it doesn't make sense to copy files into the workspace because Maven wants to download them from certain locations. So in those cases, what you can do is to use this Maven Repository Plugin. And what this does is that each of the build, if you look at the CI history, there's like 40 different builds, and each of these binaries gets a separate Maven repository view, which is nothing more than just a file that's laid out in certain structures so that Maven would recognize them as a Maven repository. So in this way, you could direct the Maven to download the right binary that has the right label, even without manually updating all these snapshots into different release numbers and stuff like that. So it's a really nice complementary tool for this kind of work. Okay, so far I was focusing on these lower level building blocks, but as probably was a bit evident in my demo, it's not very obvious how these things are put together from outside. As a person who knows how to configure these plugins, you can make everything work, but it's not very obvious from outside. Right? So perhaps you see, so one of the challenges in Jenkins, for example, is if you're building these workflow by using upstreams and downstream relationship, which is what we call the triggers, then you really sort of have this microscopic view of the workflow. You can see where this node is related to the neighbors, but you don't get this big picture of the whole workflow. So that is where the dependency graph plugin would come in. It uses this open source tool called GlassFish, developed by AT&T, to generate the graph of the relationships between different jobs. So here, the screenshot is depicting relationships between 3 different jobs. The black line indicates the trigger relationship. So here we can see that the build would trigger the test, and if that runs successfully, it runs the deployment. You see this another blue line here, which indicates that these are the flow of the files as implied by the copy artifact plugin. So if you have these jobs that using binaries, that produces a certain kind of dependencies, and you can see them in one big view, one big graph. And then these nodes are clickable, allowing you to jump to those job definitions right away, providing a bit more comprehensive view of the whole thing. Another really useful plugin is this build pipeline plugin. It basically shows the same thing, but from a different angle. Now, in the previous screenshot of the dependency graph viewer plugin, we are looking at the relationship between different jobs. But here, the way you read this graph is by looking at the relationships between different builds. So we're basically doing the same thing. The build is triggering test, the test is triggering deployment. But as an individual developer checking in the code, what you really care about is how far your change has gone through in this pipeline, not so much about how jobs are configured between them. So this view is probably more useful for people committing changes, whereas the previous view was more useful for people configuring jobs. So this orange bar here indicates a single episode, meaning every time a new commit is made, it creates this new instance of the pipeline or the new bar. The color convention here, because this plugin, the developer of this plugin didn't follow the standard Jenkins color convention, is a bit different. The yellow here actually does not mean the tests are failing, but it just means something is in progress. And likewise, the blue here, they don't mean it's success, but it just means things haven't yet done. So this provides a nice representations of what the this provides a nice representation of what changes are in the system. So this is taken on a smaller example, but as I start the new instance, because I don't really have a source code, you see that this build is complete, and then it will start trigger the dev test, and then it should complete in time. I guess now it failed. And then so now the developer knows that this failed. I could actually simply rerun this guy. And I made the dev test in such a way that this should actually succeed. So you see that it provides a different kind of visualization to the whole data. Okay, so that's good. Yes, so I guess I demoed that. And then the other thing that I wanted to touch on, which is a bit tricky to explain because this isn't as visible as it should be, it's called fingerprints. The reason I think it's useful is because it provides yet another angle to look at the same data. So far, we thought about two different ways to look at this, what's going on inside the Jenkins, right? If you think of this, if you step back a little bit from Jenkins and then try to think of the sort of airline industry, how the passengers flow into the airport, to the check-in, and go through these processes and then hop onto the airplane to land on the other side. There's a bit of analogy we can draw from this to the Jenkins. So as a designer of the airport, I guess they get to decide how these individual checkpoints are put together. So normally the check-in counter comes first, followed by the security check, and then maybe the immigration. Right? So these are chained in certain order, which is not all that different from people defining jobs and workflow in Jenkins. You're designing how these processes take place in what order. And then if you're looking at individual process, let's say if you imagine this monitoring camera behind the immigration guy, what you see is the passenger come in and the guy would stamp the passport and the next thing happens, which is a little bit like the builds going on. Right? He's basically repeating the same process over and over again, and those are what we call as builds. Now, so we looked at, in the earlier, we looked at these two ways to sort of skin the data from two different angles, but the one angle that was missing is sort of the perspective from a single passenger, like let's say myself. If I'm going through, if I'm traveling from, let's say, San Jose to the Stockholm, Arlanda, I'd be going through all these processes. There's a number of checkpoints I go through in San Francisco. I took the airplane, and I land in New York, do another processes, and so on and so forth. So what corresponds to that on the Jenkins side, in my mind, is the fingerprint of view. The reason this is useful is because Now, the person in this example is really sort of like a file, the artifacts that you're producing, right? If you think about the life of the artifact, right, as it gets created, it gets tested, and then it gets deployed, and then it gets performance tested and so on. If you can see what happened where from the single binaries perspective, it tells a lot about the quality of the binaries. That's in fact how you can determine the quality of the binary primarily. So the fingerprint is actually nothing more than the MD5 checksum of the files. And it gets recorded as the builds happen. So basically, whenever this file is touched on, everywhere in these jobs, it appears, its fingerprints are recorded. So it's a little bit like the big brothers making sure what he's doing. And then now the separate test job runs, and then it sees the same file because it knows that the fingerprints are the same. Then now Jenkins can tell that, oh, this binary that's tested here actually came from here. So that's how you could establish the exact audit trail of how this binary has came from. And what makes this really useful is that it doesn't really matter how these files come from here to there. I showed you one way to do this, which is a copy artifact plugin, but that's not the only way you can do it. You could deploy this through, let's say, Gem server, or maybe it's going through a company Maven repositories, and it doesn't really matter. And so that makes this awfully useful, regardless of the shape of the workflow you might have. And when you have these fingerprints enabled, you could compare things side by side and then track the exact status. So here we have the build job contrasted by the test job. The way you read these relationships is because the binary that's appeared here is actually tested in here. And the binary that appeared here was tested in there. Now, if you're only looking at this side, it almost looks like every build that's produced is of good quality. But indeed, if by contrasting to the right-hand side, we can tell that some of them aren't actually good. So here, for example, the build 1 has all failed the test, and that only gets recovered in the build 3. So this probably means there were some regressions here. Or if you're looking at here, you can tell that, oh, the test has failed, but indeed, in the next test run, it was still using the same binary, but it passed OK, which probably means the binary was OK, but it was a problem in the test job. So by contrasting these different angles, the new sort of degree of information shows up that's not previously available, and that's the value of the fingerprint. Okay, so in this way, so far what we've been looking at is the way to aggregate these results, the individual builds. We should look at the 3 different ways to look into these data. But what we didn't talk about is to aggregate the definition of the workflow, right? So far, all these jobs are individually defined. The relationships captured in some of these configuration files, there was really no single place where you can see them all. So there's a number of plugins developed in this space as well to address this problem, to let you define a single workflow as a single workflow. It provides a much better visibility into how you're orchestrating these jobs. So, excuse me. So the one is the build flow plugin. So what this does is it brings in the Groovy DSL for choreographing the job executions. And it provides a number of high-level primitives that you can use to drive Jenkins. So here, for example, you got the one function call, which is really invoking build and then waiting for its completion. And the result of the build is captured in B, the variable. And here we have the construct that runs these 2 closures in parallel. So in this case, it's running 2 builds in parallel. And notice we are also passing in the parameters. That's how we primarily control the behavior of the jobs. And we wrap the whole thing in the guard rescue, which is really like a try finally block to make sure that even if this fails, it successfully tear downs the whatever setup that was necessary. So again, let me quickly show this. So here, what I did was you create the new job type that says a build flow. So I've already, because my Groovy foo is somewhat limited, I already created one here. So here, what I'm doing, let's say, is I'm calling 2 jobs that's specifying different parameter. They're called name. So actually, let's see the definition of the say hello job just to make sure that it's properly parameterized and all that. So here it is, it's parameterized through the name, And the way we are using it is simply by echoing back this name. So, it's not doing that much. However, so now we go back to the flow, and then if we execute this build flow, as your script executes and call into the different jobs, it will keep track of how these dependencies had happened, and it will provide these visualizations as well. So as we make this more complicated, you can do a whole this visualization become a whole lot more useful. So maybe I would say hello JFocus, and then that would sort of give you another graph, the visualization that looks slightly different. So that's the kind of things. I guess it's the one arrow is missing. Looks like I shouldn't try new things in the demo. Huh? But so this is the kind of thing this plugin is capable of doing. And what's really neat is that this is a Groovy DSL. This is a full-blown general-purpose programming language that you can use. So as your workflow gets more complex, if you start thinking about, let's say, your company's patch release process, where you might have, you might need to talk to different databases or the different systems that you build over time, you can very easily do these things by using this plugin because it allows you to talk to just about anything by writing Groovy script. But the problem with that plugin is that it's a programming language, so it's both blessing and a curse, because as a programmer, you thrive in that environment, but for just about anyone else, it's basically meaningless block of text that they don't understand what's going on. So yet another plugin that lets you create this whole workflow definition is called the Jenkow Plugin. This uses the BPMN workflow, which provides this graphical notation of the workflow. And these steps that we are writing here is basically coding into Jenkins builds. And this is a very simple workflow that starts from here, execute two things in parallel, wait for them to complete, and then do some things, and then complete the whole thing. But it does a whole lot more than this. You have a timeout, so for example, you could say, well, if this portion is taking too long, it escalates to the administrators, or you could also define some processes that involve human beings. You could say, before we get to this phase, let's wait for somebody else to chime in and visually inspect the changes and approve. So if you're really thinking about creating a large workflow that almost inevitably you need to have some human involvement, right? So those things you could still incorporate into this kind of things. And then as I'll demo this, and to demo this I need to switch to the different Jenkins instance. So allow me a bit of time here. Oops, no, that's not where I want. Yeah, so what's really neat about this plugin is that the definition of the BPN workflow can be edited inside the Eclipse IDE, and these things are actually defined in terms of the XML files. So again, if you are working for a kind of place where you value the workspace, chances are good that these things you can't really modify very easily. They have to be actually sort of agreed upon by many people and whatnot. So this is the file that defines the workflow. And as you can see, this guy is calling the job name step 1, that guy is calling job name step 2, and on the right-hand side you see all these different constructs that you can use in the BPMN workflow, including the subsequence and then the timeouts and stuff like that. But we could, let's say, we can add one more task executions, and then we could basically just drag and drop the whole thing, which is, let's say, kind of fun. So I added one more step here, although the graph doesn't look as pretty as it could be. I mean, you get the point, right? So now I'm ready to save this. So I saved it, and then I can commit this change. Actually, I didn't specify what task to invoke here. So let me just call the another step 1. Doesn't really matter what it is for the purpose of the demo. So now I saved again, and I'm ready to commit. And I would say updated release workflow based on the supervision of J-focus audience. Right, so I commit this change, and then I could now push this into Jenkins. So the way, what I want to show you is when I push to the upstream, oops, oh yeah, here it comes. Yeah, my actual upstream is the Jenkins server. This is the, oops. My actual Git repository is in the Jenkins. So this is where it's described that where the upstream needs to be. And then I'll be able to simply push these changes into Jenkins, and then it will now reflect your changes. So again, if you're in an environment where this kind of thing is useful, chances are good that you're running multiple instances of Jenkins. So in this way, you could very easily deploy version-controlled workflow into different instances. You can run a test instance to verify the workflow before you roll out to a bigger scale. You could apply all the same philosophy you apply to the code to the workflow definitions. So this is where we actually use the workflow. It's a dedicated job type. Basically, all I'm doing is invoking this BPMN hello workflow that we just modified, and then I'll just run the build, and then that translates into the workflow executions. Also, unlike the build flow plugin, this is a fully asynchronous process. So if, say, imagine you have a very complicated workflow that spans multiple days, you can shut down the Jenkins instances and you can reboot the instance back, and then the workflow will be back at the exact same state. So again, that adds yet more flexibility to the kind of things you can do with Jenkins. Let's see, I need to pick up the pace here. Now finally, thus far we looked at the two different ways to choreograph the workflows, right? The build flow and the Jenkow plugin. What we actually didn't do is to define everything in one place. In both these plugins, the actual job definitions are still in individual jobs, right? So you're not really defining the whole thing. You're just defining the choreography in one place, which is good, but sometimes you need to go to the one step further. So that's what, for example, the job DSL plugin do. It's yet another Groovy DSL, so all the same reasons why the DSL is great applies here. And in this case, what it's doing is looking at all the branches in the GitHub, and then for each branch, we are creating a new job. So in this way, the whole thing itself, this script itself can be run from Jenkins. So if you use this, the end result is that you have a new Jenkins job created for the branch automatically. So in this way, you have all the job definitions defined in a single place, and you can very easily imagine that this can be extended into the workflow definition as well. Now, the challenge with this kind of thing is to learn the language of the DSL. It's not very probably obvious like how these things come from. So often a lot more practical way is to use this using statement, which basically says, well, basically just load this job, and we're going to only make changes to these little things here. And so in that way, you could minimize the amount of learning you have to do. It actually provides a lot more. If necessary, you can go down to the XML definitions and so on. And so there's quite a bit of flexibility. But again, the same course applies that this is a programming language, so it takes some dedicated person to maintain. Now, if your need is not that complex, you can also do something very simple, like using this CLI, the command line interface to Jenkins, to create and read and update and delete jobs. So here in the screenshot, we are accessing Jenkins command line interface through SSH. So what I see as Jenkins as a server name, the Jenkins actually does implement its own SSH server endpoint. And this command that we are specifying, these are not the commands that are available on the server computer, but it's actually the sort of virtual commands that are exposed by the Jenkins SSH. So here, what this command does is to produce the XML definition of the job into standard output. So we are then using a good old stream editor to replace certain text and then send it back to this job definition by updating job. So if you repeat this, if you sort of do a for loop on this, then you can easily create a script that sort of updates this Git URL from all the jobs that you have. So this is often the kind of easy things you can do that's really convenient. And then because this is actually workspace, for example, one of the other thing we do at CloudBees is we provide a templates plugin. Right? This shares the similar traits as the job DSL in the sense that you are defining the definition once, and then you can generate lots of, the variants, basically cookie cutter, the same thing over and over, but it uses GUI, and so that provides yet another way that doesn't require you to learn the DSL. So so I guess in conclusion, there's lots of useful building blocks available if you need it to start creating a bigger workflow automation. So I think the time is quite ripe, for all the reasons to start expanding the domain of automation a bit further across different teams to the deployment to whatnot. So I hope you'll be able to use some of these things to make it happen. So with that, I think my slides are over. So if there's any question, I'd be very happy to answer. So the question was, well, is there anything you can do to copy artifacts between Jenkins plugins? I'm sorry, the Jenkins masters. Yes and no. I don't think there's any dedicated plugin like copy artifact plugin, although at the same time, these artifacts are exposed through the REST API, and then that provides the authentication and so on. So you can have another Jenkins instance or any other system that talks to the Jenkins and grab the files. So that's probably what there is. Okay, I guess if there is no further questions, thank you very much for coming, and I hope you enjoy the rest of the day. Thank you very much.